All right, properties of functions, unit review, functions and transformation. So this first problem, we're given a one-to-one function and asked to find its inverse. Remember, a function has to pass the horizontal line test in order to find an inverse. So you guys know what square root of x minus 5 looks like. You know that that is the parent function. It is radical x. And radical x looks like this. We're just talking basic shape. X-intercept, y-intercept is 0, 0. And minus 5, that transformation is moved right 5 units. So that shape is absolutely going to be a one-to-one function. It passes the horizontal line test. That's what one-to-one means. So we can find the inverse. That's something that you always want to check. If you're asked to find the inverse, an inverse has to exist. Let's go ahead and graph our original function. It says graph f and the inverse of x and y equals x on the same axis. So we'll start by graphing our inverse. So we're going to move right 5, and then we're going to do our pattern. Our pattern for the square root of x is over 1 up 1 over 4 up 2, and that's all we can fit here. Now, if you remember the property of inverses, you switch all of your x's and y's. So you could go ahead and graph those ordered pairs right now. I'm going to wait and find the inverse and then graph my ordered pair. So there's my original function. That's f of x. Let's find the inverse. Oh, let's actually do domain and range first, since we're working on that. So the domain, the x values we're using are 5 to infinity. And in interval notation, 5 to infinity. And the range is 0 to infinity. Our lowest y value is 0. All right. That's all the details of our original function. Now let's find its inverse. So to find the inverse, we change f of x to y, switch x and y, and solve for y. So I need to solve for y now. So to get y all by itself, I have to undo the square root first. So I'm going to square both sides. And then to solve for y fully, I need to add 5 to both sides. I know that's the easiest step, but it's a mistake I make even sometimes to not switch that sign. So make sure, show all of your solving steps so that you don't make a silly mistake that messes up your whole problem. So x squared plus 5 is our parent function is x squared, normal old parabola, and our transformation is moved up 5 units. The thing that we have to be careful about when we start to graph it, so if I move x plus x squared up 5 units and start graphing over 1 up 1, over 2 up 4, over 1 up 1, over 2, 1, 2, 3, 4. Those ordered pairs, all of those ordered pairs can't be the inverse for our original function. And so just be really careful and make sure your domain of your new function is restricted. Your domain of your new function should be equal to the range of the original. So the range of our original function was 0 to infinity. So the domain of this guy should be 0 to infinity. So our inverse is just that part of the curve, not over here. So I'm going to erase that just so the other part of our curve is gone here. You're going to want to look for those restrictions to start problems and to end problems when you're dealing with maybe a situation where that restriction is necessary, like x squared. X squared is a really good example, or 1 over x squared. If your function doesn't pass the horizontal line test, you have to do some kind of restriction, either to find the inverse or for the inverse to exist. Our last piece here is the range. The range of our original is the domain of the function. Range are the y values we're using. Our range here is 5 and above, so that's going to be 5 to infinity. Remember, when you're using videos, pause, see if you can get ahead of my steps. Pause to catch up. If I go too fast, that's a great thing. I can go pretty much as fast as I want on the video, and you can pause to get ahead, catch up, stop the video altogether if all you needed were the first 2 steps. So hopefully you're using the video basically in the most efficient way possible. All right, come see me if you have questions.